Okay guys, this video is going to show you how to do test corrections on your Chapter 5 test on the problems you missed. So first of all, we go over how test corrections work really quick in case you forgot part of it. So you're going to have this correction sheet, and remember, for each problem you missed, a sentence explaining what you did wrong, then that's not supposed to be resolve, it's supposed to be resolve with a dash, showing your work and all the details, then one sentence explaining your new solution. Don't forget to do all three parts for each question, or you won't get your correction points. Okay, so here's an example. So pretend this part right here is actually on the blue paper, okay? So say that was a problem on a test, and the blue is what I did, the work I did, and I messed up somewhere in there. So on my test, I got it back with wrong. So here's what I got to do. This down here is the part that is actually the corrections. So this is on my test. This is me correcting that problem. So first part, what did I do wrong the first time? I forgot to divide the 6 by 3. Okay, that's what where I messed up the first time. B, resolve it, showing all those steps and getting the right answer this time. So I redid it, doing it correctly, and I got my final answer. Make sure show the work and write the final answer. Don't just do the work. Don't just do the last step. Show all of it. Then the end, an explanation sentence of what you were doing right here and why and how. I divided the whole left side of the equation and the whole right side of the equation by 3, then simplified to get x. Okay, don't forget to do all three parts for each question that you correct. And then when you get to the end, don't forget to staple this paper together with your test paper and turn them in together. Okay, don't just turn in the white paper or you won't get all your correction points. You got to turn them in together so I can look at them both together when I regrade it with your corrections. Okay, I think that's it for correction instructions. Though I feel like I'm forgetting something. Remember, include all the steps. Oh, one other thing. Let's say that on the test, you just totally blanked and you didn't put any of this stuff. You didn't even try because you just totally forgot how to do it or just didn't know and left it blank on your original test. For part A, you can say, I didn't know what to do and I didn't do it on my original test, or I didn't try, or something like that. So, but you still have to do part C, explaining what you did on this part. You have to explain that. On part A, if you didn't try on the first time, just say, I forgot how to do it, I didn't do it, whatever, that's okay. If you didn't do it, you didn't do it. But on part C, you've got to explain your new solution, whether you did stuff or not the first time. Okay, enough rambling, let's get to the test corrections. So obviously, if you got a problem right, you can skip through that part of the video to the ones that you need help with figuring out on your test corrections. Okay, on this first question, if you have the yellow version of the test, version 2, then go find the other video like this that has the yellow test. This is for people with the blue test. Okay, number 1, log base 7 of 343 equals 3. How do you write that in exponential form? You say the base to the power equals that thing that you're taking the log of. So if you're not sure that that's right, you can plug in this part in your calculator and make sure it equals 343. That's right. 7 times 7 times 7 equals 343. Okay. So that one's with numbers. It's easy to check and make sure that it makes sense and works. This one, number 2, isn't as obvious. So you have to kind of figure it out from this one if you need to. Use this one as a guide. So let me kind of show you how I'd reason that using this one as a guide. Okay, the y here is like the 7 over here. First of all, if you read the instructions carefully, I'll pull this back for a second. If the equation given is logarithmic, rewrite it as exponential. That's number 1. It gives you logarithmic, we rewrote it as exponential. Number 2 is this second part. If it's given in exponential form, rewrite it in logarithmic form. So we're going backwards on this one. We're going to take exponential form and turn it into logarithmic form. So we're taking this, which is comparable to that part, and we're finding this part, which we're going to write right here. So log the base, which here was the 7, that's going to be y. So it's going to be log base y of, what's going to go in there? It's on this one was the 343, which was this part, which is the x over here. The x here is where the 34 is here. It's 343. So we're going to put the x in there equals, what's the answer to the log? The answer to the log is the exponent on the exponential form. So the answer is 3. Okay, and you can test that going backwards. Say, okay, the base to that is the power equals this. Is that what this says? Y to the third equals x. Wait, what happened to my -4? Where did I get 3? Oh my gosh. That should be -4. I was mixing up these two. So equals -4. Okay, the -4 here is like the 3 over here. There, we're good. Okay. Base to the power equals the thing in the log. Base to the power equals the thing in the log. Okay, we're good. Number 3, evaluate. Calculator not required. 4 to what power is 16? That's what a log means. That's what a log means. 4 to something equals 16. If you're not sure, you can check in your calculator. But 4 to the first is 4. 4 squared, or 4 to the second power, is 4 times 4, which is 16. So the answer is 2. Okay. This one, log base 3 of 81. So how many 3's do you need to multiply together to get 81? And you can check that. 3 times 3 is 9, times 3 is 27, times 3 is 81. So it takes 1, 2, 3, 4 3's multiplied together to get 81. So that would be 3 to the 4th power. Okay. Now we're going to use calculator. Number 5, you just use the ln or natural log button and type in 57, press enter, and it's 4.04305 blah blah blah. It says round to the 1000th, so we're gonna leave it right there. 10th, 100th, 1000th place. Log base 3 of 17. We don't have a log base 3 button, so you got to use the change of base rule, which should have been on your little flip chart that you could use on the test. So you have a log base 10 button on your calculator. So you're going to do log base 10 of 17, close parentheses, divided by log base 10 of 3 to change the base. Okay, you should have had in your notes on the flip chart how to do that. Nice and easy. Type in your calculator, log of 17 divided by log of 3, or you could do ln, natural log of 17 divided by ln of 3, and you get the same thing. It's 2.57. It's 89, so I'm going to round that up to a 9, and that's 3 decimal points. Okay, let's keep moving. Number 7. Okay, to undo e to the power of something, I'm going to have to use natural log. But before I can do that, I need to get this part isolated. Okay, so that's negative 6.5 times e to that stuff. So to get rid of multiplying by negative 6.5, I'm going to divide by negative 6.5. And I've got to do it to both sides. So I'll pop that in my calculator, divide to 1 on this side, which is what I want. And my calculator, 28 divided by 6.5 is 4.30769, blah, 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 blah. So put a few decimal places out so that I don't round too much. Don't just put a 4 and call that good. That's craziness. Okay, so I have e to the x minus 10 equals 4.30769. Times 1 doesn't change that. Okay, to get rid of e to the power of something, I'm going to do natural log of that, which means I need to do natural log of that. So those are going to cancel out with each other, or undo each other, I should say. They're inverse operations, and just leave x minus 10. This, I'm going to use the ln button on my calculator. Natural log of 4.30769 is 1.4604. Now what am I going to do? I'll zoom out so you can see this whole thing that I've been doing here. Okay, to get rid of minus 10, I'm going to add 10. To get rid of subtracting 10, add 10. So x minus 10 plus 10 is x plus 0. And that's going to be 11.4604. So x equals 11 point, it says final answer, round to the nearest thousandth. So I'm going to put 460. And yes, technically you should put the 0 to be to the thousandth. But if you just put 46 and didn't write the 0, since it's a 0, I didn't mark anything off for that because that'd be a little too crazy. Okay, let's go to number 8. How do I get rid of adding 4? Divide by 4, because I want that e to the power of stuff by itself before I can use the ln, natural log of both sides. Okay, subtract 4 from both sides. I'll get e to the negative 5.6v equals 38.6. Okay, if you're not sure, use your calculator for that. Okay, now I'm to the point where I can take natural log of that and natural log of that, and I guess I should have the arrow going the other way. Stick that in the natural log, stick that in the natural log. Okay, natural log of that will just leave me negative 5.6v. natural log of that, I need to use my calculator real quick. ln button 3.38.6. That'll be 3.65325, etc., etc., etc. That should be enough for our purposes. Oh, what do I have to do to get rid of multiplying? Multiplication, the inverse operation to a multiplication is division. So divide both sides by negative 5.6, and we will get v equals divide by 5.6, 0.652 36647. Wait a second, nearest thousandth. The next number is less than 5, so I'm not going to round up. I'm just going to cut it off right there. Okay, there we go. Now let's continue to number 9. Okay, it tells you in the instructions exactly what to do. Let that focus for a second. Solve for x. Focus, focus. Sorry. Solve for x, then switch x and y. Okay, step 1, solve for x. Step 2, switch x and y. Okay, let's do number 9. Solve for x. That means get x by itself. So first let's get rid of that minus 10. We'll add 10 to both sides and get y plus 10 equals natural log of x to the 4th power. To get rid of natural log of something, we're going to say e to the power of that equals e to the power of that. So e to the y plus 10 power equals just x to the 4th. Kazam! Okay, now you could say we're taking the 4th root, like this guy, or equivalently, meaning it actually means the exact same thing, we're going to do the 1/4 power of both sides. Okay, now I'm just going to be careful here. 4 times 1/4 equals 1, so that's just x to the 1. Or if you're doing the 4th root of something to the 4th power cancels out, and it's just x. Okay, power of a power property for exponents. You gotta remember exponent rules. 1/4 times this. I'll show this in 2 steps just to be really clear. 1/4 times y plus 10. And then, sorry, that keeps focusing too much. Okay, 1/4 times y, 1/4 times 10, e to the 1/4 y plus 10/4 equals x. Okay, that's not completely the invert. We solved for x. Yay! X is by itself. Now we got to do step 2. Switch the x and the y. Easy. The x becomes a y, and the y becomes an x. And 10/4 would be the same as 5/2. If you wrote 2.5, I'll call that equal because it is. Okay, and if you want to say y equals e to the 1/4 x plus 5/2, even better. Okay, number 10. Same idea. Gotta solve for x, then we gotta switch the x and the y. So first, solve for x. That's the most of the problem. We get y plus 1 equals -9. So just to be clear here, natural log of x, it's -9 times that, then minus 1. So -9 times this, minus 1. Okay. So here's what we've got now. To get rid of multiplying by -9, we're going to divide by -9. Okay, and we could separate this to -1/9 y plus -1/9, but that would just make it more complicated in my humble opinion, so let's just leave that how it is. Y plus 1 over -9 equals -9 divided by -9 is 1. So that's just natural log of x. Okay, so now is where, let me use a little color, brighten things up around here. E to the power of that stuff equals e to the power of this. And e to the power of natural log of something is just whatever the something is. So it's just going to equal x. So e to the power y plus 1 over -9 equals x. Now we got to do step 2. Don't forget step 2, switch x and y. So the x becomes a y, the y becomes an x. And that's it. If you wanted to put the negative up to the top, that's okay. So y equals e to the -x minus 1 over +9. That's okay too. Good, good, good. Let's go to number 11. Okay, this is expanding on this page. That means separate it out as much as you can. So this first one right here, it's one big log. We're going to separate it into multiple logs using our log properties, which you should have had written in your flip chart, which should have helped you a lot on the test. So log of something divided by something equals log of the numerator minus the log of the denominator. Oh, we just took one log and made it into 2 logs. But also, can we get anything else out of this log? Use the product property to say, oh, log of something to a power is the same as the power times the log of the thing without the power. Minus, same thing here, 3 log of 11. Okay, that's using 2 properties, the quotient and the power property. Let me up here at the top write the 3 properties. There's only 3 log properties you have to use for all these expanding and contracting questions. First is log of a divided by b equals log of a minus log of b, which is what we just used on number 11 for the first step. That's called the quotient property. Second is like it, but instead of division, multiplication. Log of something times something equals log of the first one plus log of the second one. And whatever the base is for the logs has to stay the same the whole way through. Okay, and the last one is the product one, which I just mentioned for our second step here, which is log of something to a power equals the power times log of the something without the power. Okay, so those are the 3 powers we're using, which hopefully you had written out with examples in your flip chart thing. Okay, so this one, there's a couple ways you could do it. What shall I do first? Let's do the power property with this 5. So the 5 will come out there, which is this property right here. It's stuff to a power, so the power will go to the front of the log. 5 times log base 8 of x times y to the 4th power. Okay, now I'm just gonna focus for a second on this part and write it in here. And we'll come back to the 5 in a second, but it's 5 times log of this stuff, but we can separate this piece into 2 separate logs. Log base 8 of x plus log base 8 of y to the 4th. That's this property right here, the product property. Product is things multiplied together, a times b, product of a and b. Okay, or in this case, the product of x and y to the 4th. So, I'm just going to rewrite that, except this one right here, I can apply the power property again and put that 4 right here. 4 log base 8 of y. Now we got to use the distributive property, our basic simple algebra stuff that we learned a long time ago and hopefully haven't forgotten, and distribute the 5. So 5 times this term plus 5 times that term, because they're being added together. So 5 log base 8 of x plus 5 times 4 is 20 log base 8 of y. And there we have it. Those are fully expanded. Let's do number 13 real quick. I won't stop to explain as much since we've already done all the properties on the previous 2. Man, sorry my camera's having issues today. There we go. Focused on the scribble. Okay, first we'll do power property with the 4. It's log base 3. Don't forget to write the little 3 on all the logs. U to the 3rd over v equals 4 times. We can separate this log into 2 logs with subtraction. Division inside the log becomes 2 separate logs subtracting the log of the top, or the numerator, minus the log of the bottom, or denominator. And I'm going to use the product property here real quick and say that's 3 log base 3 of u It's just a coincidence that those are both 3's. The 3 here came from that 3. And now I'm going to distribute 4 times this minus 4 times this. So 4 times 3 is 12. And 4 times 1 is 4, or negative 1 would be negative 4. So we've got 12 log base 3 of u minus 4 log base 3 of v. Hooray! Sorry this video is getting a little long, but like I said, just skip the problems you don't need. Okay, this side, same rules, or properties I should say, but we're going backwards. We're condensing. So we're taking this log that's already expanded and going backwards, getting it into one big log with everything on the inside of it. So first, what's going to happen with the 3 and the 2? Think of the properties we just used. What would expand to put numbers in front of the logs? Oh yes, you are right. If this was 2 to the 3, it would make that 3 go there when we were expanding. And likewise on this one, what's going to happen? You're right. It's going to be 5 squared. And subtraction, how could we condense subtraction? What can subtraction, how could we be, you know what I'm saying. And you're right as usual. It's going to be 2 to the 3rd over 5 squared. Subtraction with 2 separate logs of the same base, of course, will become division within a single logarithm. Everything's inside that one single log, so we're good. This one. Okay, we'll first do that power property and make it log base 7. Oh, this one's base 7 too on the logs. What do you know? Strange coincidence. Which it is a coincidence. Okay. What does the addition of 2 logs, how can that combine into a single log? What will happen? It's going backwards of what we're doing on this page, right here on number 12. How do we get addition? From multiplication inside the log. So the addition is going to become, on this one, multiplication inside the log. Log base 7 of 3 to the 5th times 5. You could put to the 1st if you want there. Don't have to. Or if you wrote it in a different order because you wanted it to be special and different, 5 times 3 to the 5th. I guess that's okay too. However, on this one, you may not switch the numerator and denominator because that makes a difference to what it equals. Okay, enough rambling, enough nonsense. Let's go to number 16. Okay. Well, this one, there's a couple things you could use. You could say, well, if the log base 19 of that equals the log base 19 of this, then that must be the same as this. They must equal each other. Or you could just say, to get rid of log base 19, I'm going to say 19 to the power of that equals 19 to the power of this. Either way, you're going to just end up with x plus 4 equals 5x minus 3. And technically, you'll need to check your answer at the end to make sure x plus 4 is greater than 0. Or you could check that 5x minus 3 is greater than 0. But if one's greater than 0, obviously the other is greater than 0 because they're equal to each other. Anyway, let's continue. What am I going to do? I'm going to solve for x. Let's subtract x from both sides. 5x minus x is 4x. If that confuses you, pretend it's negative 1x. Or minus 1x. So 4x minus 3 equals 0 plus 4. That's not a plus, that's a minus 1x. Sorry if that looked like a plus x. X minus x, or you could say 1x minus 1x is 0. Okay, so we have 4 equals 4x minus 3. I'm going to add 3 to both sides so that all that's left on this side is x's. And that will tell me, adding it up, 4x, you could say plus 0 if you want there. 4 plus 3 is 7. So what am I going to get? Divide both sides by 4. 7 divided by 4. Let's just write that as a fraction. 7/4 equals x. If you change it to a decimal by dividing, I guess that's okay. if you changed it to 1 3/4, I guess that's okay too. I would just leave it like this. Okay. Oh, and by the way, to check it real quick, is x plus 4 greater than 0? This thing plus 4 definitely greater than 0. Or 5 times that minus 3, is that greater than 0? Yeah, definitely greater than 0. So we don't have to worry about it being a no solution trick question. Okay, this one. We're gonna, instead of 19 to the power to get rid of log base 19s, we're gonna do 3 to the power of something to get rid of log base 3s. But first, we've got to combine the logs so that all that's on the left side of the equation when we do 3 to the power of it is a single log base 3. Okay? Don't start right off the bat doing 3 to the power of this whole bunch of stuff, because that's 2 logs being subtracted, added together. Don't try to 3 to the power of that whole big jumble of stuff. Make it a log base 3. A log base 3. Then the 3 to the power will cancel nice and neatly and simply and wonderfully. It's nice and easy to do too. Remember the log properties we were just talking about a couple pages ago? Yes, this is simply as you were just thinking a moment ago. Log base 3 of x minus 5 over 7. Now you're going to 3 to the power of this side equals 3 to the power of that side. Now that we have a single log base 3 of a bunch of stuff, now we'll do that. Because now, yes indeed, log base 3 to the power of it is going to just leave x minus 5 over 7 equals, what's 3 squared? Not 6! 3 times 3 is 9. Now, nice and easy to solve that. We're just going to multiply both sides by 7. 7 times 9, you can use a calculator if you need to, it's 63. Or you do your finger trick. I won't show it to you now. Ask me about it if you wonder. 7 divided by 7 is 1, so it's just x minus 5 times 1 over 1. Now we'll add 5 to both sides. Hopefully this isn't confusing you. Feel free to ask me if I'm throwing off your groove here somehow. 63 plus 5 is 68. You threw off my groove. Okay, that's a 38-minute video. Let's stop right there, and thanks for doing your test corrections. I really appreciate it. Make sure to turn them in by Friday. Friday's the end of the term. OMLOTFL.